What kind of triangle is this right here?
That is a right.
A right triangle. Good job. Let's put another triangle. If I gave you this triangle without any marks on it, what kind of triangle is that?
It's acute.
Good.
Acute scalene.
Good. What makes it acute? Scaling. I think there's an E at the end of that.
Oh.
All right, acute scaling. What makes a triangle acute scaling?
Acute is when it has like these angles that are less than 90.
Good.
And then scaling is because it doesn't have any no two lines or
No
three
two
lines.
marks to show it's equal?
Yeah.
Awesome. So if I was to take this triangle right here and shrink this down a little bit. Oops. And then take this triangle out of here. And if I put these marks on it right here. All right, what would that make that triangle now? If you
That
saw
would
those
make it
two
an
marks?
acute isosceles.
Good job. And then last thing, what if we took that and I put all the marks around it are equal, and then know that these angles are equal to. All right, what would you call a triangle like that?
Acute equilateral.
Lateral, good job. Good job. And then do you remember the name in fancy geometry terms we call for equalness, things that are equal? Remember, it starts with a C, do you remember?
Congruent.
Yep, congruent is geometry's fancy word for equal. All right, so let's have you hand me the pen. Let's take this guy. All right, you ready? So it's not a right triangle. So I'm not going to have you put that mark. Not going to be right. But in there, I'm going to put 2x plus 4. The other angle up here, this corner is going to be x. And then the one up there is going to be, let's make it 26 degrees. All right, so knowing the parts of a triangle and the angles that they add up to be, solve that algebraically for x.
It's not a right triangle?
It's not a right triangle. Nope.
Okay.
Solve for x and then plug x back in to find
Like that?
the angle. There you go. Perfect.
Okay. So then you can combine these numbers. So it would be 3x plus 30
Yep.
equals 180. And then I can minus 30 by each side.
Good.
It would be 3x equals 150.
Good.
And then you would divide 3 by each side. And wasn't it like 50?
Yep. So x equals 50.
So it would be x equals 50.
All right. Now, if we asked you, okay, give us the angles. What are the measurement of the angles?
So this one's just x, so it's just 50.
Good.
And then this one you have to plug it in. So it would be 2 times 50, which is 100, plus 4, which is 154. Or 104.
104. I'll delete that so you can write that in. So 104. All right. How do you know that those angles add up to be 180? Or how do you know that they're proper? Or can you check to see if they're 180?
Yeah, so
plus and minus.
104 plus 50 plus 26. 10, 5. Is that a 6 or a 2?
That's a 2.
2. 8. 180.
There you go. So you know the difference. All right, now I'm going to give you a straight angle. So here's a straight angle cut by another angle. So if we add these two angles up, what do we call those? Do you remember?
I forgot.
They also add up to be 180. Starts with an S. They're
supplementary.
Supplementary. What if you have two angles, a right angle that's cut in two pieces? What do we call those two angles?
Adjacent.
Adjacent, good, right next to each other. But if two angles.
Oh, complementary.
Complementary, good. So can you write that for me on here so you can see? Supplementary adds up to be 180, right?
I do not think I spelled that right.
Good job, close enough. And then this is complementary, which adds up to be
90.
Good job. All right, now I'm going to take those and have you practice some problems with those. If I can just get this part right here. All right, I'm going to have you turn these into some algebra problems. Are you ready? Okay, for that first supplementary one, I'm going to have the first angle be 4x plus 20. And the other one's going to be 2x plus 40. Try that one. I'm hoping it doesn't give you a decimal. But add those up to 180. And solve for x.
Okay, so
do that.
I'm gonna
make it full screen. There you go.
I'm gonna add it by like 4x.
Yep.
Plus 20.
Good.
Plus 2x. Plus 40 equals 180.
Good job.
And now we could like combine them.
Good. Combine
so
like term.
4 plus 2 is 6x.
Yep.
And then plus 60
Good.
equals 180.
Good.
And then we're going to minus it by 60 on each side.
Good job.
And then this is just 0. 76x, or 6x. Yeah. And then
6x equals
120.
Good. And then what's your last step?
Divide 6 on each side.
Good. Algebra.
And that would just be 60. No.
So 6 goes into 12 how many times?
Twice, so 20.
So x equals 20.
X
there you
equals
go.
20.
Good job. And now that's not the angle. What?
Oh, yeah.
The actual angles up there, so x is 20.
You have to plug it in, so it would be 20 times 4, which is just 80.
Yep.
And then plus 20, which is 100.
100.
So the angle is 100 for this one. And then for this one, you would have to multiply 20 by 2, which is 40, plus 40, which is just 80.
There you go. And those are your supplementary angles. There's your 80-degree angle, and then there's your 100-degree angle. Good. And then this is not the angle, but the answer for x used to find the angles. All right. So here's a much easier one where it's just plain old x. We don't have to plug in anything. So this complementary one, I'm going to make one of them x, and then the other one, let's make it 2x. There you go. So one you might have to plug in. So solve that pair, that adjacent pair, that's complementary. Solve that for x.
Okay, so now we can combine, so it can just be 3x equals 90, and then divide it by 3, divided by 3.
Good.
What's 3 and is it 30?
Yep.
Okay, yeah, so it would be x equals 30, and then for this one it's easy, it's just 30.
Good.
But then for this one you'd have to multiply by 2 since you have to plug it in, so it would be 60.
Excellent job. And those add up to be 90 complementary. Yeah. Good job. All right. Now I'm going to be saying some kind of triangles, and I want you to try your best to draw it. It doesn't have to be perfect. All right. I want a scalene isosceles triangle. Can you try to draw
a scalene?
I'm sorry. An isosceles acute triangle. An acute triangle with nothing more than everything less than 90, and then isosceles.
Like that?
And then what marks would you make as perfect? Can you label that acute isosceles? All right, can you make an obtuse scalene triangle? An obtuse triangle with an angle bigger than 90.
Oh wait, I did that wrong.
That looks good. There you go.
And saline?
So can you label that obtuse? And then we call it scalene. And what is a scalene triangle? Do you remember what makes a scalene triangle?
Nothing is like congruent.
Yep, none of the sides are the same. Good, none are congruent. Good. Can I have you draw a right triangle?
Mm-hmm.
And then what mark do we put on there to show that it's a right triangle? Good. So that's the 90-degree angle, right? When he talks about a right triangle, has he talked about hypotenuse or anything like that? Okay. Can you label that right triangle? Good, righty. I'd like you to try to draw a right isosceles triangle. Good. What marks can you put in there to make it? I'm thinking if you had a right isosceles triangle, the equal marks have to be on either side of the right angle. Have to be here, here. Because it wouldn't make sense to have these two be the same. But yeah, so label that a right isosceles. All right, next one, can you draw an obtuse isosceles triangle? Very nice. And label that obtuse isosceles. Good job. And what makes a triangle obtuse again?
When one of the angles is more than 90 degrees, but then the other two are acute.
What makes a triangle acute?
When the angles are all 3 less than 90 degrees.
Good job. What makes a triangle a right triangle?
When there's a 90-degree angle and then the other 2 are acute.
There you go. How do you know a triangle by looking at it? Is isosceles, like what marks
There's 2 little marks on it.
They tell you the equal sides. Good. Can you draw a equilateral triangle?
Just any type of triangle?
Yep. Equilateral with 3 equal sides. Very nice. Can you label that best you can? Equilateral. Acute. Good.
I think that's how you spell it. I really don't know how you spell it.
I'm a bad speller myself. What other kind of triangles are there?
I don't really know.
I mean, there's the acute ones, there's the obtuse ones, scaling. We did same side equilateral. All right, I'm just going to stop it right here.